Okay, so in the previous video, we were able to discuss the different postulates that we can use to prove that two triangles are congruent. Now, let's further our discussion and let's talk about several methods or other methods for proving triangle congruence. Let's start by having this theorem. So, it says here that if two angles in a non-included side of one triangle are congruent to two angles in a non-included side of a second triangle, then the triangles are congruent. You say that this one is actually the side angle, or this is angle side congruence theorem. Okay? And since this one is a theorem, of course, that we need to prove this before we can use it. But before we'll go to the proof of this theorem, let's just first unlock some unfamiliar terms, which we have the non-included side. When we say non-included side, the congruent sides are not between, okay, the congruent angles. Okay, now, so given that, say for example, we have this triangle, let's draw a triangle. Okay, this time this is a triangle with two triangles with a common side, and let's say this one is LOVE. Okay, and let's have our given. Let's define our given. So according to the hypothesis that we are given two angles in a non-included side, so let's say that angle LEO is congruent to angle VEO. Also, angle L is congruent to angle V, and segment LO is congruent to segment VO. Okay, so according to the hypothesis of this theorem. And for the conclusion part, let's prove that triangle LOE is congruent to triangle VOE. Okay, so first things first, let's indicate our identical marks so that you'll be able to see it clearly. So from the given, angle LEO is congruent to angle VAO. So this angle is congruent to this angle. Angle L is congruent to angle V. And segment LO is congruent to segment VO. Okay? Now, so given those information, we are now ready for the proof of our theorem. So these are our proof, or this is our proof rather. We have our statements and the reasons. So of course we'll start with the given. So our given is that angle LEO is congruent to angle VEO. Also, angle L is congruent to angle V. And also from the given, it said that segment LO is congruent to segment VO. Okay? And again, that is from our given. Now, so from the information, we already know that LEO and angle VEO are congruent, so as with angle L and angle V are also congruent, which are two angles of the triangle. So therefore, we can also say that angle EOL, okay, angle EOL is congruent to angle EOV, okay, is congruent to angle EOV, okay, and this is by the law of detachment, because the two angles of the triangle are already congruent. Therefore, it follows that the third angle must also be congruent to the third angle of the other triangle. That is the law of detachment. Okay? And since this angle is already congruent to this angle, and we can say that segment EO is congruent to itself by the reflexive property of congruency. So if this part is congruent to this part, therefore we can say that triangle LOE, we can already say that triangle LOE is congruent to triangle VOE. Okay, by we already have two sides which are congruent in the name of LO and VO, as well as EO and EO itself, and an included angle to these sides, which is EOL and EOV respectively. So therefore, that is angle side angle congruence postulate. Okay, so we're able to show that the theorem holds. Now let's have an example. Okay. Given that ray BZ or WZ bisects angle TWV, and segment WT is congruent to segment WV. Let's show that segment TZ is congruent to segment VZ. Okay, so let's put our identical marks already. WT is congruent to WV. And now, so since WZ is the bisector of angle TWV, okay, then we say that the angle bisector bisects the angle into two congruent angles. So we can say that angle TWZ is congruent to angle VWZ. Okay, by the definition of angle bisectors. Okay, so we are now ready. So let's have our proof. Now our statements and our reasons. For number one, again, it's given ray WZ bisects angle TWV, TWV. Okay, and this one is given. Okay, as we have said a while ago that WZ is the bisector of angle TWV, and what bisectors can do is angle bisectors can do is to divide the angle into two congruent angles. So therefore it follows that we have angle TWZ is congruent to angle VWZ. Okay, and because that's the definition of angle bisectors. Okay, now from the given figure we can also say that WT is congruent to WV. So WT is congruent to WZ, which is the information is coming from our given. Okay, so what information can we still get from our given figure? We can see that WZ is congruent to itself. Okay, we can say that WZ is congruent to WZ, and that is reflexive property of congruency, so that we're able to show that, you can see in the given figure, we're able already to show that there are two triangles congruent already, because the two sides are congruent and their included angles are congruent. So basically we can say that triangle TWZ is congruent to triangle VWZ. Okay, VWZ, and this one is because of the side angle side congruence postulate. Okay, and since the two triangles are already congruent, we have established already that the two triangles are congruent, so we can take the converse of that definition. So we can now say that therefore TZ, or segment TZ, is congruent to segment VZ by CPCPC, or corresponding parts of congruent triangles are congruent. Okay, that's the converse of the definition of congruent triangles. Okay, and this ends our proof. Another example, given that ZW is congruent to YX, ZY is congruent to WX, and let's prove that ZY is parallel to WX. So our knowledge for the parallel lines that we discussed in the previous chapter is now essential. Okay, so as we see here that there are already identical marks from our given, so let's now have our proof. We have our statements and our reasons. Okay, as always, we'll start with the given. Okay, so segment ZW is congruent to segment YX, so as with ZY is congruent to WX. Okay, and that is our given. For number 2, we can say that ZX is congruent to XZ. Okay, so ZX is congruent to XZ. It's congruent to itself. Okay? And that is because of the reflexive property of congruence. Notice that we already have our side here, and other congruent side here. So basically, we can now say that triangle WZX, okay, triangle WZX is congruent to triangle YXZ, okay, YXZ. And that's because of the SSS congruence postulate. Okay? Now, so since the two triangles are congruent already, what we can infer is that angle 1 is congruent to angle 2. And that is because of CPCTC. Corresponding parts of congruent triangles are congruent. Again, we are using this because we're able to show already that the two triangles are congruent, namely WZX and YXZ. So it follows that its parts in this particular example is angle 1 and angle 2 are also congruent, and that is by the CPCTC. Okay? And since we know that ZX is actually a transversal of WX and ZY, we can infer that angle 1 and angle 2 as alternate interior angles. Okay? Again, ZX here can act like a transversal to segment ZY and XW. So it follows that angle 1 and angle 2 are alternate interior angles. And what do we know about alternate interior angles? They are congruent. So therefore, if they are already congruent as shown in statement number 4, we can now say that ZY is parallel to WX. And the reason is, if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Okay? And this ends our proof.